Okay, today's lesson we are going to be doing some linear programming problems, which can get to be a little bit tricky, so hang in there with me. I'm going to try to explain this step by step. Basically, it's putting systems of equations into real-life context and figuring out how to typically maximize or minimize something that you are trying to do. It happens a lot in real life when you're trying to maximize profit or minimize expense. Those are typically places that you will use these, okay? First of all, I'm going to just give you a problem that is just a bunch of equations similar to the process that you're going to use, but I want to do it not in context first so that it's not quite so confusing, okay? So I want you to notice in this problem that I first of all give you an objective function. That's that f equals 7x plus 4y that you see right here. We are not going to touch that right now. Just know that it's there. That is the function that we will be trying to maximize or minimize later. I am not going to do anything with it right now, but we will come back to it. Okay, so what happens is you are typically given some restraints or some restrictions on a process. And so what you're needing to do is you're given a set of equations that have to be satisfied so that you can figure out sort of what your corners are, what your key points are. Okay, the first thing I want you to notice is this. I'm giving you these constraints that my x values have to be greater than or equal to 0 and my y values also do. X values greater than 0 means you're limited to the right half of the graph. Y values greater than or equal to 0 mean you're limited to the upper half of the graph. The place where those intersect is up here in the upper right-hand quadrant of the graph. And so I am not, just so you know, going to color on this graph at all anything with those two inequalities, just because it gets so messy up here and it's hard to erase. So I am not ignoring them, but I do want you to pay attention to that limits your graph to the upper right-hand quadrant, okay? What I gave you then in my red equation is this right here. This is in standard form right now. If you got it into y equals mx plus b form just by solving for y, this is the inequality that you would get. I know you know how to do that, so if you want to write that down, you certainly can. Okay? I personally think it's easiest to graph these equations using their intercepts instead of graphing them in y equals mx plus b form. Okay? So that's what we're going to do. So we're going to take this red equation and we are going to find the x and the y-intercept. So the y-intercept is where it crosses the y-axis. Anywhere along this line, the x values are 0. Okay, so to find the y-intercept, you're going to plug 0 in for x. You're going to pretend this is an equal sign, and you just get y equals 60. So my y-intercept is 0, 60. Pay attention to the scale. This is an 80 up here, so this is 10, 20, 30, blah, 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 okay? So 60 will be right here. So it crosses the y-axis at 60. Then, to find my x-intercept, I will plug 0 in for y. 60 divided by 5 is 12. So it crosses my y-axis at 12. So right about there, okay? I will connect these with a solid line since it's underlined. Okay, I'm going to limit myself to the upper right-hand quadrant since we've talked about that. That's a horribly crooked line, sorry. And because my symbol is greater than, I know that I need to shade above this line. That's all the shading I'm going to do because this is going to get messy, okay? Anywhere above that line. All right, on to the blue line then. Okay, for the blue line, if I leave it in standard form to find my y-intercept, I put 0 in for x. So that means I have 6y equals 60, or y is 10. To find my x-intercept, I put 0 in for y, and I have x equals 60, so it crosses the x-axis at 60. Again, I will connect that with a solid line since it's underlined. And since it's greater than, I will also shade above that line. Okay. Next equation. Y-intercept means I'm going to put 0 in for x. and I get 6y is greater than or equal to 204. When I divide 204 by 6, I get 34. So it crosses the y-intercept right here at 34. And then to find the x-intercept, I put 0 in for y. 204 divided by 4 is 51. So 51, let's see, 10, 20, 30, 40, 51 would be right about there. Again, it's underlined, so I'll connect that with a solid line. And I would also need a shade above that. Okay? So now, the actual solution is any place where you see all three colors. That's bounded by the y-axis here, this red line here, the green line until it hits the blue line, this line right here, and then the x-axis. So really my shading is this entire region right here. Okay? So that's how that goes. Now, what you need to do is you need to figure out where all the corner points are on that region. Okay? Here's one corner point right there. It's where the red line hits the y-axis. The red line's intercept, remember, was at 60. So this is the point 0, 60. Okay? I'm actually going, 0, 60. Here's another corner point. This corner point, you can see, is where the red and the green line intersect. Okay? The red and the green line intersect. So the red line is 5x plus y. I'm just going to pretend it has an equal sign in it right now. And the green line is 4x plus 6y equals 204. Okay, now, I know you know how to solve that system of equations. If that was a system of equations, you would solve that. You could either do it by substitution, you could do it by elimination, you could do it with matrices, or you could put the y equals equations into your graph and then graph those two lines and figure out where they intersect. But you need to solve that system of equations because that's the point where the red and the green line intersect. Okay? And the red and the green line intersect when you solve that system of equations at 630. Okay, so when I solve that system, I get 630, which makes that coordinate right there, 630. This coordinate, okay, is where the blue and the green line intersect. So the blue is x plus 6y equals 60. And the green again is 4x plus 6y equals 204. Okay, I need to solve that system, again, either by substitution, by elimination, by matrices, or by graphing the lines on my graphing calculator and figuring out where they intersect. Any way you want to do that, it doesn't matter to me. But when you do that, you're going to get the point 48, 2. Okay, so this coordinate is 48, 2. And then here's your last corner right here, and that is the x-intercept of the blue line, and the x-intercept of the blue line is at 60, 0. Okay, then I'm just going to list these coordinates right here. I'm going to say what my corners are. Okay. So, just again, my corners were at 0, 60, 630, 60, 0, and 48, 2. Okay, then I am going to go back up to that objective function that I told you we were going to come back to, which is right here, and that is 7x plus 4y. Okay, so that's 7x plus 4y. And what I want to do is I want to plug each one of these points into that objective function and see what I get. Okay, so this first one I'm going to plug 0 in for x and 60 for y. So I go 7 times 0 plus 4 times 60. And when I do that, I get 240. Okay, on the next one, I will do 7 times 6 plus 4 times 30. Okay, and when I do that, I get 162. On the next one, 7 times 60 plus 4 times 0, and I get 420. And lastly, 7 times 48 plus 4 times 2 gives me 344. Okay, so this is what I can say. I can say that the max is 420 at 60, 0. The min is 162 at 630. Okay, and that is sort of the process that you're going to use. And it's a long one, but you can do it. All right, now we are going to put this into context, into an actual problem. Okay, so here we go. We are talking about Johnson's Produce, who's purchasing fertilizer with 2 nutrients, that is nitrogen and phosphorus in it. They have to have at least 180 units of nitrogen and 90 units of phosphorus. Their supplier has 2 brands of fertilizer for them to buy. Brand A is $10 a bag and has 4 units of nutrient and 1 unit of 4 units of nitrogen and 1 unit of phosphorus. Brand B is $5 a bag and has, you know what, this is a typo. It should be 1 unit right here of each nutrient. Okay, Johnson's Produce can pay at most $800 for the fertilizer. How many bags of each brand should be purchased to minimize the cost? All right. So first of all, we have to figure out what our variables are. And if you, they're trying to figure out how many bags of each brand. That's the question. How many bags of each brand should be purchased? So we're just going to call X the number of bags of brand A. Okay, and we're going to call Y the number of bags of brand B. All right. Now, what they're trying to do is they are trying to minimize their cost, okay? That's your end goal here, is that you're trying to minimize your cost. So, and that's your objective function, your cost, okay? It costs me $10 for every time I buy a bag of brand A. So that is going to be 10x, okay? It's going to cost me $5 every time I buy a brand B bag, which we call Y. That's my objective function. I am not going to do anything with it right now, but I'm just going to remember that it's there. Okay, then I need to give myself some constraints. I've got some restrictions. First of all, I can't have a negative number of bags of brand A. So I know that my X has to be greater than 0. I can't have negative bags of brand Y or brand B, so my Y has to be 0. Okay. Then it's telling you that you have to have at least 180 units of nitrogen. Okay, so let's make an equation for just the nitrogen. Okay, so for the nitrogen, I get 4 units from every brand of bag, or every bag of brand A. I get 1 unit, there's a magical 1 there, for every bag of brand B, which I called Y. And that, when I put those 2 together, the nitrogen from brand A and the nitrogen from brand B, I better have at least 180 units. Okay. It also says that I have to have 90 units of phosphorus. Okay, so this is my equation for the nitrogen. Then I'm going to make an equation for phosphorus. Okay, and for phosphorus, I get let's see, I get 1 unit from brand A, and I get 1 unit from brand B. So there's ones right here. And when I put that together, I have to have at least 90 units. Okay. And then it's telling me I can't spend any more than $800. Okay. So I'm also restricted by my spending. So my spending in this case, again, I can't, it costs me $10 for brand A, it costs me $5 for brand B, and I can't spend any more than $800. Okay? So here we go. You are going to take the time and you are going to graph each of these equations. I know you know how to graph these, so I am going to just hit pause on this video and I am going to let you graph them, and then you can compare them with mine, okay? So hit pause, you try them. I'm going to come back in just a second. Okay, so this is what your graph should look like, similar to this. Mine is not real accurate because I didn't draw real straight lines. If you have a ruler, yours is probably better. But it should look something like this. Be really careful because with that green line, because it was a less than symbol, you needed to shade underneath it. So when you darken in the places where all 3 colors overlap, it should be where that black triangle is. Okay? So first of all, your job is to figure out this coordinate right here. Okay, that coordinate right there is where the red and the green line intersect. So the red and the green line, you know, means that it is 4x plus y equals 180. And 10x plus 5y equals 800. Okay, those 2 lines intersect at the point 1040. Okay, so that coordinate is 1040 right there. Okay, then we need to find this coordinate right here, which is the red and the blue line. Okay, so the red and the blue would be 4x plus y equals 180 and x plus y equals 90. Again, solve that system any way you want. Substitution, elimination, graph the lines, whatever you want to do. Those 2 intersect at the point, let's see, 3060. You can see mine's a little off because I didn't graph real accurately, but that's the point, 3060. And then the last one would be this one right here, which is the blue and the green line. Okay, so the blue and the green line. That means I'm going to solve the system, x plus y equals 90. And 10x plus 5y equals 800. All right, I will figure out where they intersect. Again, substitution, elimination, graph it on your calculator and figure it out that way. When you do that, you get the point 70, 20. Okay, so that's the point 70, 20. Now it says to plug the corners of that into the objective function. Okay, so again, I'm just going to kind of make a little table. My corners are at 30, 60, and 10, and 140, and 70, 20. Okay. My objective function, if you remember, was 10x plus 5y. Okay. And I am trying in this case to keep my costs as low as possible. But I'm going to go 10 times 30 plus 5 times 60. When I do that, it costs me $600. If at $10 a bag, I buy $10 of brand A, and at $5 a bag, I buy 140 bags of brand B, it will cost me $800. If at $10 a bag, I buy 70 bags of brand A, and at $5 a bag, I buy 20 bags of brand B, it will also cost me $800. Okay? So the cheapest thing I can do is right here, okay? The least I can spend, the minimum cost, I'm going to put this in a sentence. The minimum cost is $600 when they buy 30 bags of brand A and 60 bags of brand B. Okay, so that's that. That's a long process, but you can do it. And lastly, you guys, this is another situation. All we're going to do is write the equations for this. We're not going to graph, but I want you to practice writing the equations. This is talking about a manufacturing company that has factories that produce 3 grades of paper, a low grade, a medium grade, and a high grade. They need to supply 24 tons of low grade, 6 tons of medium grade, 30 tons of high grade. At factory A, they produce 8 tons of low grade and 1 ton of medium grade. You guys can read this. 2 tons of high grade daily, and it costs $2,000 to operate. At factory B, they produce 2 tons of low grade, 1 ton of medium grade, and 8 tons of high grade paper daily, and it costs $4,000 to operate. How many days should each factory operate to fill the orders at minimum cost? Okay, so first of all, you need to define the variables. Okay, so there's 2 things going on. There's factory A and there's factory B. So X is going to be the number of days that factory A operates. And B will be the number of days, or Y, I'm sorry, will be the number of days factory B operates. All right, what we are trying to do here is we are trying to minimize the cost. Okay, sometimes you're trying to maximize something. If you're trying to make the most amount of money, then you want the max. In this case, I'm trying to minimize the cost. And in this case, it cost me $2,000 to operate factory A, and it cost me $4,000 to operate factory B. Okay, then my constraints. Obviously, I can't operate a negative number of days at factory A, so that has to be greater than or equal to 0. Can't operate a negative number of days at factory B, so Y has to be greater than or equal to 0. Okay, and then what I need to do is I need to think about what else is shaken down here. Okay, so they need to supply 24 tons of low grade paper. So we're going to make one equation that addresses the low grade paper issue. Okay, and it's saying that at factory A, they can produce 8 tons of it in a day, and at factory B, they can produce 2 tons of it in a day, and I have to have at least 24 tons of that low grade paper. Okay, then for medium grade paper, at factory A, they can do 1 ton a day. At factory B, they can do 1 ton a day, and I have to have at least 6 tons of that. And then for the high grade paper, they can produce 2 tons at factory A, 8 tons at factory B, and I have to have at least 30 tons of it. Okay, so that's how your equations would look like that on that one, and then you can certainly graph them and go from there.